So I have a quick question for you guys. Say we have a kid who wants to go to her school and she has three possibilities. One, she can directly go from her house to the school, straight road. Another, she can go to her friend's place and go with her to the school. Third scenario is she has to buy something. She has to go to the stationery shop, then join this road and then travel with her friend. There are three different paths. So a quick question is over here. Will the result change? There are three possibilities. Will the result change? No, right? Now, will the distance that she travels, will it change? Yes, right? Third question is, will the calories that she burns in each of this path, will it be different or same? Does it depend on the path or not? Yes, right? So this path, the shortest path, ideally it will take less time and less energy to travel than your path 2 or 3. So these two are said to be path functions. These two are said to be path functions. Technically no, but these are examples of or close to being path functions. So in thermodynamics, we have heat and work to be path functions, guys. So what is not a path function? I'll give an example. That is your internal energy. Okay, so internal energy is not path function. So this is what we are studying over here. So we are studying about path function, and that heat and work is path function. Basically what it means is, say I can take any system, say a piston. It has a particular pressure and a volume, and then after some time the pressure drops and the volume increases. So the piston can vary the pressure and volume in this phase, or it can go this way also, or it can go this way also, so on and so forth. There are many possibilities. The heat and the work of the system, it depends on which path we are taking. The heat and the work in the first case is not the same as second or the third, and vice versa. So you can flip around. So each path has its own heat and work being done by the system, on the system, and so on and so forth. So like how we have here, how the distance and the calories burned by the kid is different for each case. Similarly, when we change the system's pressure and volume and all of that, the heat and the work will not be the same. Heat consumed or heat given, work being done or work done on the system will have a different picture altogether. So it's not only that the initial and the final destination is same. It's not only that. When you talk about heat and work, you need to understand that it is a path function. That is, it depends on what path we are taking. It's a very important aspect. Based on this, we talk about few engines, ideal engine actually. It is an important concept for the future discussion, and that topic is very important. If you don't understand this, it's a simple fact, but if you don't take it into account, it will be very confusing. Okay, so a very simple concept. I have a small write-up. You guys can read through. Let me help you guys. So here I have a small write-up to talk about path function. If x, any given quantity, is defined as a path function, then this particular variable, its specific path taken must be considered. To talk about x, we need to talk about the path it takes from point A to point B. For example, when you're traveling to school from your place, you can take shortest path, a longer and a crowded route. So here the distance walked and the calories burnt, it depends on which path you take. So similarly, work and heat also get influenced in what path you are taking. So here the way you go is a path function, right? If you have to talk about these quantities, by discussing how it's being done, the path taken, then it's known as path function. Simple. So fact, heat and work are path functions, meaning heat and work cannot be determined solely on initial and final states. They depend on what path is being taken, right? I got a few examples over here, and all of this, yeah, I think I'll explain it later. Now, if I tell, it will be just a bouncer. Graphically, it will look like this. We have different process. Few of them are starting from A, reaching B. Actually, 3 of them. And the 4th one is just from here till here. So in each of this case, the work and the heat will be different. Right? Every point will have different work and heat. Okay, summary. Internal energy is not a path function. Internal energy of a system, it depends on P, V, and T. So change in internal energy depends on the final and the initial point. It is same for any given path. Okay, so in all of these cases, the internal energy will remain the same. Change in internal energy will remain the same. But when it comes to the work and the heat quantities, they are not properties of the system, right? They're not stored in the system. They can only be defined when the process path is known. Okay, you can see the idea adds on. When you're talking about heat and work, they are not part of the system. They're a consequence, or they do something to the system, or system does something to the surrounding with the help of work and heat. Hence, they are path functions. Okay, so system cannot contain heat or work, only internal energy. Same thing again and again I'm repeating. I could have reduced all of this. Could have done a better job, but anyways. So if you guys want to write anything from here. Again, this is just a simple idea to make you guys understand the phrase path function. So don't write that as an example in your exam. And I think summary is enough. This slide is enough.